this computer. There we go. All right, we are all set up and going here. And of course that disappears right when I do that. There we go. Oh, no yawning, Alexia. We are about to get into it here. We are going to be doing some SQL today. Happy Monday. I hope everybody is ready. Make that coffee if you haven't, because we get to go back into SQL today. If you see the bags under my eyes, your screen is not incorrect. There are definitely bags under there. I'm a little exhausted today, but I am just as chipper because I'm on my 18th cup of coffee. And you know what? Caffeine just keeps you going. I might crash here in the middle of it, but whatever. It's fine. Let's do SQL anyway. I hope everyone enjoyed last class with our SQL. I hope everyone's getting into it. For the people I have talked to, it sounds like SQL is coming a little bit more naturally. If not, of course, feel free to ask as many questions you want tonight. I'm happy to go over a couple other things. Before we dive into SQL, as always, we got our announcements. The first one up, just a second reminder here. I reminded everyone a little bit earlier that Studio 19 is going to be another graded studio. Not essentially an assignment. Assignment 4 will be our last one, but Studio 19 will be our last graded activity that we're going to be having. Again, it's just a second reminder, just to let you know so no one forgets. I'll be reminding you after assignment 4 about this. Just want to keep in everyone's heads. Second thing, on Thursday, do make sure you're here on time. I know we usually lecture around 5:40 on typical days, but we have a big surprise coming on Thursday. So feel free, or not feel free, please be here at 5:30, right when class starts, just so you don't miss any of the surprise. And then, what was the last thing? Oh yeah, I didn't put a note in here for this, but don't forget about your lift off opt-in form that Greg shared last class. If you're excited for lift-offs as much as I am, please get into that form, fill it out, and get that information in so you don't skip a beat after this class. Don't forget, graduation is right around the corner, so hopefully everyone's excited. Everybody excited? Graduation? Almost there? Kinda? No, not really? Meh? Okay, well, I'm excited. That makes one of us. There we go. Thank you. All right. Any questions about the assignments? Any questions about anything minus the material tonight? Julie, thank you for clapping. Yeah, what's up?
When is assignment 4 due?
Ooh, trick question. You're starting out with the hard ones today, Alexia. All right. Anybody know exactly when assignment 4, what is it?
March 29th, I thought.
March 29th? Yeah. It won't be due yet. We have a few more classes. We have to cover 1 or 2 more concepts for it to be finished. So thank you. The 29th. Cool. All right. Any other questions? Anything else? If not, let's get started. We're just going to go back here. Just help me out here. I'm just starting out coding. I'm going to give you some questions. Please help me to fill in these answers. The first one being, if I want to get data from a table, I would use what keyword?
Create table.
If I want to get data from it?
Select.
Very good. Select. That's when we want to get data from our table. That create table will help us construct it so we can store data in there later. The next question is, I need to add the annotation what to create a JUnit test?
At test.
Very good. At test. Don't forget about these annotations. They're not going anywhere. We're just giving them a small break. If you need to, go over the annotations just so we don't forget any of them. The next one is, when I want to protect code against an error, I'd use what?
Verification.
Say that again.
Is it error?
It's not error. We use a certain
Try
kind
and
of
catch.
tool. Very good. A try catch. A try and a catch. Typically, you hear people refer to them as try catches. Don't forget, we use these to catch exceptions or those errors. And this is how we protect against them. Next one is, if I want to create a string in SQL, I use what?
Varchar.
Very good, varchar. That was a good one. And then when I add blank tag, it starts creating a website. What tag do we always use first to start creating a website?
HTML.
No.
HTML. You can also say doc type, but the next one down would be the HTML as well. So in here, I just put HTML, but very good for the doc type. If I send a request, who receives it?
The controller.
The controller. Very good. The controller gets those requests and sends us back responses. Those requests being gets and posts from what we've seen so far. The next one is I want to combine two tables of data. So I'd use what in SQL?
Join.
Join.
Very
Join.
good, a join. Awesome. So yeah, we'd use that join to combine those two tables. Crazy enough, it's a great segue into getting back into SQL. Like our chapter says, it is the sequel for SQL, so we're going to be talking more SQL. So let's bring back those tables that we worked with all of last class. The first one being our dog table. We have our dog ID, dog name, dog age, dog owner, and is dog good, those columns. If we wanted to create this table, we would use this query. We say create table, like someone already discussed today, and then insert all of our columns here. So I'm going to go ahead and run this. So this is our SQL query to run this. Do note that if you want to run an individual query, make sure you are highlighting it. The next thing to get information in there are these inserts. Just to do a quick review. I highlighted both of them because I can highlight as many queries as I want to run them. So I highlight them and I run it. Now, once I run this, to double check, what should I always do after I create a table and insert data? What should I do?
Refresh.
Very good, refresh. So I'm gonna refresh all just to do that. And now I see I have a table in there. And then how would I do just a quick query on this?
Hover over the tab and go to the right to that paper looking thing.
Very good. Yeah, just use that icon. And what it does is it just does a select here. So we just want to make sure that our data is actually inserted. And I see that I actually did something incorrect there. I didn't update the update table. I need to change that ID for that dog. So update. This is a great test here. Update table. And then what do we need to put next here? I just want to update my dog's ID. What do we put here to update it?
That's it, yeah.
It's a table.
It's just the table name, my dog table. Right there. I want to say set. I want to say, what would be dog ID equals to 2. Oh, you know what? I cannot do this. Dang it, dang it, dang it. That's going to be annoying. So, oh, you know, I can. Okay. Update table, my dog table, sets dog, dog ID equals to 2. Where, very good. Dog name equals Odie. There we go. I'm going to highlight that. Why are you complaining here?
Yeah, that's not supposed to be there.
No, it's not. Update, where, oh, update. Why I messed this up today too also. Was it update from?
I think it's just update.
Is it just update?
Yeah, I think it's update and then the table name.
Thank you, okay. I always get that one mixed up. Not gonna lie, I write these all down. All right, there we go. Perfect, let's just requery that. So I'm gonna highlight that, run it. And there we go, everything's updated. Great throwing back into the deep end of SQL, fantastic. So we have this table created here. The second table we were gonna do is the owner table. Don't forget about this owner table. So we're gonna come back over here. We're gonna go back to our queries, and then I just have these out here for a little bit of time. So I'm gonna run this create table. I refresh once again, and now I see that my second table is there, and then I'll insert that data. There we go. So I'm gonna go ahead and query that. And looks like all of my information is there. So this is our reintroduction into the MySQL workbench, as well as creating those tables and inserting that data. Now that we're finished with that, let's move on. What if I wanted to get more information about our owner? Well, with this, what I would typically do, as we saw in last class, is that we connect our dog's owner's names. So we see that Kyle is connected to Kyle here. So what word again would I use specifically here to connect this information between these two tables?
Join.
Very good. We're going to use join. So we very minimally talked about join in our last class. And I know we kind of skipped over, just not skipped over, but we didn't get too much into depth. So that's why I wanted to take this class really to get into the meat of it. So let's go ahead and talk about them. We're going to bring back host tables, and we're going to talk about the joins. we're gonna talk about which join specifically we would wanna use in that case where we just wanna add more information about the owner to our query results. So the first one is the inner query, or sorry, the inner join. This inner join will only include data that we have in common between the two tables, depending on the conditional. What I mean by that is that we use that on keyword in our joins, which we'll see here in a moment. We see that Kyle is connected between the two dog owners. So therefore, for this inner join, these should be connected in our query results. And we should only see these things. We should only see Waggy, and we should only see Kyle. So let's go ahead and take a look at that a little bit closer. So we're gonna say select star from, we're gonna do my dog table. And say, I'm gonna do that there, inner join. And we're gonna do the inner join on the owner table, where owner, yep, we gotta also, so when the two names are the same, so we saw that owner name is the same in both of our tables, we have to make sure that we specify which table we're talking about when we call out one of the column names. So that's what I'm gonna do here. I'm gonna say my dog table dot owner name equals owner table, age owner table dot owner name. So I run this, and I completely did not that. Do that. Go. What am I doing here? Oh my gosh.
I think the names are different in the
Did
table.
I totally did name it wrong, didn't I? Which part are you seeing exactly?
Go back to the tables, the two tables.
Oh,
So you have one
oh,
There's
owner
a
name
dog
and
on
one.
there. Yeah.
oh, thank you. It's dog owner. Okay, I'm just getting my two slides mixed up. So dog owner, thank you. Dog owner, there we go. There we go, perfect. So now we see we get back a single query result. Take note of that. Thank you very much for the help, by the way, as well. So we see that Waggy and Kyle have been combined. This is our inner join. It combines common data. So this one is very helpful when we just want to get back what is in common. So let's keep moving forward. The next one is the left join. Now, left and right aren't always very obvious when it comes to computers. So that's why I want to really point out that over here, the left table would be my dog table, the from table, and the right table would technically be the owner table, the one that we're pulling the information from into our results. So when we say left table here, I want to combine my dog table's information and then query that against a conditional, again, that owner name and dog owner. So it would connect directly to this result. So what does this mean? This means that all of the entries from my dog table will be in my results, but only the things that match in the owner table will be shown in my results. Let's take a closer look at that. So if I do a left join here, what that's going to do is that it's going to bring back Waggy and Kyle and combine that for us. But it also brings back Teresa now and Odie. But it doesn't give any information here because, as we know, we don't have a Teresa in this owner table. So it combines everything from the left-hand table, everything's back in our results, that's great, but it only takes things from the right table if they match. So let's keep moving forward. We also do with the right. So we have left and right once more. And the same thing kind of happens that we just talked about, just opposite or flipped. We take everything from the right-hand table, we match it with anything from the left-hand table, which is our dog table, and then we show that result. Showing that here, what we do is we take that, run it once more, and now we see that we get back Waggy on the left-hand side here, and then a null, but then we have Kyle and Sarah. with Kyle and Waggy matched up, but Sarah not matching up to anybody because she doesn't have one of the dogs in our dog table. Now, these are 3 joins, and the joins can be the tricky part of SQL. So I just want to see if anyone has any questions about that.
So is left always just your first table, and then right would be the second one, or how's I'm still?
So left would be your from table,
Yeah.
and the right table would be the one that's next to join. That's a good way just to kind of identify.
Okay.
So just think, it goes from left to right, just like typical English reading. So you'll go from your left table to your right table.
Okay.
So then any left join could be simply written right tables.
Curtis, you were breaking up there.
Sorry. So any left join could be rewritten as a right join by flipping the table listing.
Absolutely. So we take that, we highlight it, we run it, and now you see that everything is just flipped. And Lisa, to answer your question, which the question is, why do we both have a left and right? Couldn't you just flip them in the statement? That's correct. But I promise you that in larger queries, left and right keywords will come in handy, where you can't just flip them as easy as this. We're just looking at a very simplistic query, but in more complex ones, both words will come in handy. You would have to do both. I forgot the syntax for the full. I'm going to look that one up, but that was the last one I was going to do. Adam, your question, or Adam's question was, you have to do both in MySQL to get the full outer. And also, yeah, thank you, Adam, for explaining the purpose also of a left and right. In a more complex query, such as the full join, you would use the left and the right and a union. Let's see if I can do that real quick. I always forget this one. There we go. Yeah, it's like something like that. I always forget. I'm missing something in my full join. But if you do want to see the full join, which I personally have never used the complete full join just yet, do look it up in your text. If we have time at the end, I'll definitely get that correct syntax. But the book has a really good representation of it. All right, any other questions about these joins? All right. So like I said, the full join is the one that just completely, utterly just meshes the 2 tables together. So that would be it. And I'm thinking maybe I need to take now. No, I won't spend time on that. All right. So out of all these joins, which one would we probably want to use to combine our owner data with our dog data, our 2 tables? Anybody have a preference? If we just want to equally match up the dogs with the proper owners that are in our information.
Inner
Which join?
join.
The inner join, very good. We're going to want to use the inner join here just to get back the valid dog to owner query results. So that's what we'll do. I'll just put that in here for right now, and we've already seen the results for that. I just want to make note. All right, moving on. So we have our inner join, and so we do our selects. We do that dog name, we do from, and then the table name. We do our inner join. We just went over this a little bit more in depth, and then on, and then our actual conditional. So this is the typical syntax for our joins.
Now, just to clarify, you don't need the name of the table after on, do you? If the names are different?
I would say keep the names in there.
Okay.
Yeah, for safety purposes, because you're talking about 2 tables there, keep the name of the table in there and then use that dot and specify. Technically, I think it will be forgiving, but in the future, it's not, it's just, it's unsafe, essentially, in the end.
Best practice.
Best practice, yep. Great question. Great question. All right, now let's look at another scenario. What if we wanted to add another owner to our owner table? What keyword again would we use?
Insert into.
Insert into, perfect. And then our table name. And then what's the next one we typically work with right now?
Values.
Values.
Very good. Values, and then we provide the values here to actually do that. When we do that, it adds another Kyle into our table. Now, I understand there's multiple Kyles out there, but hopefully we all have a bias of the best one. Just kidding. All right, insert into, and then we said we need to do the owners table, and then, values, and we have
with no S, right?
owner. Very good, thank you. Owner table, and then we're gonna have, that's gonna be an ID of 3. The other Kyle is gonna be in there, and then
Kyle.
You also missed
Yeah.
it.
You need an L for table.
Yeah.
awesome. Owner table, BLE. And then there we go.
At the end of the word table, there's the L missing, Kyle.
Okay, give me 1 second here. Gotta switch over.
Okay, there you go.
Sorry about that.
So you guys, hopefully, does this sound okay to everybody?
Yes.
Great.
Well,
Just let me know if it doesn't, and I'll get a better pair of headphones. All right, so I was hearing somebody else say that I had another error. Did someone saw?
No, it was just the L. You got it.
Okay. Mix. And then the last one was 42. All right. So we highlight that, and then why is my thing running? Sometimes SQL takes a second to catch up, but there we go. Yeah, if you do see that red under there, at least on my side, sometimes it takes a second for SQL to be like, oh, you're okay. Oh, and also I'm missing my semicolon up there, so it was technically right. So we inserted our data there. We requery our owner table for best practice, once again, to make sure we have everything there. And we see that we have 3 owners. Now, my question to everybody is, what's going to happen when we run this query? What would happen if we reran our joins?
Then it would output.
Say that again?
Then it would output the additional information.
It would,
right?
yes, it would give out more information. Let's go ahead and take a look at that. So if we now ran our select here, and we run it, we're gonna get back Waggy belonging to 2 different Kyles. Another Kyle out there is trying to steal my dog. That's not cool. So we need to do something about this. So like you said, it's gonna connect both of those to that Kyle, or both Kyles. So Waggy is gonna be connected to 2 Kyles. So what I'm trying to say here is that putting the names of dogs and owners as connections is not the best practice whatsoever. We don't typically wanna do this. Hence, we bring it back to why we put that ID column in there. So we're gonna have to change a few things about this table. So that being said, let's take a look at where everything is connected. Right now, we have it connected at dog owner. Dog owner, again, is the name of the owner, which is extremely general. There can be multiple Kyles out there. There can be multiple Teresas, etc. So this is not typically what we want to do. What we do in these tables is that we set it to an ID from another table. In this case, it's owner ID. So we set up our owner, or we set up our columns to have individual IDs relating to other tables. So Kyle would be 1 in this case. And at the moment, and then would relate to the owner ID now instead of actually the name Kyle. And then Teresa would be set to null because as of right now, we don't have a Teresa in our owner table. So this is what it's going to look like, and this is how we should connect our data as we move forward. It is not safe whatsoever to connect by just via general text. Always connect by your IDs. So taking a look at that, we always need to make sure that we connect with IDs, but that means these IDs have to stay unique. If we have 2 3s in our owner table, then the ID column, the idea of it completely goes out the window. So we need to make sure that our IDs stay unique. Now, who can tell me in hash maps, how do we keep things unique inside of that data structure?
You call in the index?
So in hash maps, we have 2 things. What was stored inside of hash maps?
Key value pairs.
Key value pairs. And the one particular thing in a hash map that kept everything unique was the key. Our keys can never be repeated. Remember that in a hash map, you can never have two of the same keys. Same with this. We need to make sure that our IDs stay unique. So we're going to make keys here in these columns. So keys keep things unique. And the one key that we've already talked about briefly today, just for a second before class started, was the primary key. The primary key is the way we identify particular rows uniquely inside of tables. So that being said, looking at the dog ID here, I want to make sure that I keep my dog IDs as well as the owner IDs very, very unique. So make sure that your primary key is the essential ID, the unique identifier for your particular row. Waggy and Odie, 7 and 4, the ages, those aren't going to be unique. Only your ID will, most of the time. Even if you feel like you're going to have a unique column, I do still recommend putting an ID column there. Kim, I just saw your question. So are there multiple ways to do that? Add a new column, alter table, and add. I think that was a question last week. As of right now, you typically want to just write individual queries to insert that data, kind of what you saw in your past studio. If I'm not answering that question properly, just let me know. But that's what I got from that. Does that kind of answer your question? All right, cool. Okay, sounds good. All right, so everyone's probably asking, I'm very excited for this next part. How do we actually set up a primary key? So let's go ahead and recreate the table. So we're gonna completely recreate our owner table first. So to do that, what we're gonna do is say drop table and then our owner table. Drop table completely removes the table from our schema. Unlike delete, which will just remove the information, but keeping the table intact. So let's go ahead and do that real quick. I'm gonna come down here and I'm gonna say drop table. And I'm gonna say owner table. But again, what this does is that it completely removes our table. So as we can see, the table is gone. It's out of here. That data cannot be retrieved through any fun means. So now that we have a completely clean slate, let's go ahead and recreate our table. The first word we use is create. Who can tell me the second word?
Table.
Table.
Table, very good. And then the name of our table. And then we start naming our columns. The first one is owner ID. And then we need to have always a data type for our column, which is going to be an integer, 1, 2, 3. And then here's our new thing. When we actually decide what we want our primary key to be, aka this owner ID, we use the keyword primary key afterwards. The next thing is auto increment. So like we just saw, we saw primary key here. We've got to make sure that primary key is after our integer there. Also remember that there cannot be two primary keys. You are going to choose one column and one column only here. So make sure you choose wisely, because it is not fun to try to change it later. Then the next thing we have here is auto increment. Auto increment, kind of like what we talked again in the very beginning of class, but I'm going to repeat it for people who weren't there. Primary key and auto increment do not always have to be together, but you do find them in tandem a lot, and you will throughout this class. Auto increment basically helps us do less work. We can choose our primary keys as long as they stay unique as much as we want manually, or we can have SQL do it for us, counting 1, 2, 3, etc. by using auto increment. So here we place auto increment because I don't want to have to make up those keys every single time. I want SQL to do it. So that's why we place that there. The next one is, again, we're just going to name our columns real quick. Owner name with our varchars, our owner city, and then our owner age, which is an integer. So I'm going to pause here. Any questions?
Question.
Yeah.
So how do we identify which key to be which one should we do it as a primary key?
So typically you're going to want your ID column to be your primary key. That's why in the last class, as well as this class, I very much stress if you create a table, have an ID column.
Okay.
So yeah, that ID column will be it. Otherwise, for some reason, if you don't want to do an ID column, ask yourself, is any part of my data absolutely unique? Maybe you're storing addresses that can only be entered once for whatever. Maybe that will be your unique key.
Okay.
Things along those lines. But I do typically recommend creating that ID column.
Now, what about you have owner ID int as opposed to integer? Is there, I thought a lot of times they use integer there instead of int.
They're really synonyms for each other. There's going to be very little difference. I don't think if any difference. They both mean the same thing.
Okay.
Yeah. If any of the TAs know exactly specifically what's different from them, please let me know. But I believe they're just synonyms for each other, just like Boolean and bool and tiny int. Just kind of give more variety and confuse everybody.
Wait, what did you just say? Because that was like totally going to be my next question. Which one is preferred for us to use in our assignments? Bool, tiny int, or Boolean?
Oh, just use all three. Honestly, that'd be fun. No, it's whatever your preference is. I use bool here, but you can use Boolean, you can use tiny int. They all mean the same thing. So as you saw in your Boolean columns, you see ones and zeros. It's literally just going to translate to a tiny int. So whatever makes you happy. But if you want to just stick with what the exercises or the studios are doing, go for it. Just note that they're all the same.
Okay, thanks.
Yeah, absolutely. I mean, I'm not gonna force anybody to do my recommendations. So I just like bool because it's shorter. And again, lazy programmer. I'll type in bool. I'm done. Four characters.
Stack Overflow weighs in on the difference between the two.
Oh gosh, what is Stack
Well,
Over? Yeah.
No. It's a simple one. It's a simple one. Both of them are synonym for tiny int 1.
Right. Exactly. Yeah. So Boolean.
So both
bool,
of them convert back to the same thing. So.
Yeah. Cool. Okay. Yeah. Yeah. Thank you for that. Yep. They're all synonyms. So integer and int. Yeah. I've never read the history of SQL and why they did the language the way they did, but I'm sure it would be a very interesting one. Marcus, I see that you're typing. Any question I can help you with?
It's actually for later. I think it's gonna come up later.
Okay, sounds good. All right, so now that we have created our table here, let's go ahead and do this actually inside of our SQL. So we'll say create table, then say owner table, and we say, oh my gosh, I always forget. We get the owner ID first. So we say owner ID, and then you guys are gonna help me out here. What's the next thing we need to put here? An owner ID is typically gonna be what kind of data type?
Integer.
Integer, yes. I'm gonna do int because it's less characters. And then if I wanna make this integer my primary key, what do I always type next?
Primary key.
Primary key.
Very good, primary key. And then if I wanna be even lazier, if I want SQL to actually create my IDs for me, what do I put?
Auto increment.
Good, auto increment. Fantastic. All right, so then we're just gonna grab over the owner name, which I said was gonna be a varchar of 50. And then we're gonna have owner city. Okay, fine. Owner city, which we said varchar of 80. And then our owner. Fantastic. All right, there we go. We are going to highlight that and go ahead and create it. Okay, any questions about this? What we just typed out. So we're gonna go ahead and insert in our data here now. This is what we used last time. And now I'm gonna change up my query a bit. Here, originally, we are creating our IDs. But we no longer have to do this. Remember, SQL does this for us. So we won't actually skip over this column. But if I did this right now, it's going to give me an error because I'm missing one thing. I need to tell it specifically what these values belong to. So over here, I put owner name, the column I want to insert Kyle into, owner city, that column, and then the owner age. Perfect. Highlight that now, and we run it. Awesome. All right, copy that. We're going to bring it down here. We'll take that value. And then paste it. Perfect. Run that. And then finally, we need to insert that third Kyle that was trying to steal my dog earlier. So we're going to say Phoenix here. Phoenix. And then what is it, 42? Cool. So we run that. And we have just inserted our data. So now we can actually go over here. I'm going to refresh just for good measure. And then rerun, not that one, rerun our owner table. And now we see that Kyle, Sarah, and Kyle have been inserted, but now our owner IDs are auto-incremented, meaning 1, 2, 3 is there for us. And SQL will keep track of this and increment as it continues. So it really helps us out here. So that is how we create a primary key and why we create a primary key here in SQL. Any questions about that? Cool. Well, then let's move on. This is the table we just created. An icon you'll typically see sometimes in renderings as well as in MySQL Workbench is a key above here. That is dictating the primary key. We just created owner ID as a primary key here. So we have a primary key. Oh, we have a primary key here. Let's bring this in and see what else we can do with it. Let's go ahead and rebuild the dog table now. Who can tell me what column is going to be the primary key?
Dog ID.
Very good. Dog ID there. That's going to be this primary key. But one thing I want to point out here is that what is this column? This column is also an ID, and it relates to different things over here in the owner table. It is technically a column of IDs. It's a column of the owner ID's primary keys. So what is it doing, and why, what, I guess, should we even conceptualize it as? Well, whenever we have different primary keys from a different table inside of our own table, we call them something different. Those are like foreign ambassadors. They're foreign keys. They're travelers from a distant land that are just chilling in our table to help relate that information better into our own. It's almost like a contract. You're promising this table, the dog table, that the owner ID that you're putting into that column exists. You're like, pinky promise, it's actually a thing. And that foreign key creates that contract. So this is what a foreign key is. It's basically that contract with another table saying, I promise this data is here. Like, pinky promise, trust me. So any questions about that one? All right. Well, with the silence, you're probably all just anticipating, excited to see how do we actually create this. So just like the dog table, what we're going to do is start out with the drop table of the dog table. Let's go and do that. Come back here, over here. Say drop table, dog table. Call it my dog table, didn't I? Yep. So we say my dog table. So I'm going to run that. And now my table is dropped. Completely gone. We go back here, and who can tell me how I can start creating my dog table again? Or who can tell me how I can start creating that?
Create table.
Create table.
Yep, create table, and then pretend that says dog table, not owner table. Small misspelling. And then we're going to start creating our dog ID. So we say dog ID int, and then what's our next word?
Primary key.
Primary key.
Primary key.
Primary
key. And then
Auto increment.
very good. We're going to be lazy together. We're going to do auto incrementing. And then the next thing is going to be our dog name. Nothing weird there. Going to be a varchar 40. Our dog age is going to be an integer. Our owner ID, which is going to be an int. And then our is good dog as a boolean. Nothing weird has been here except for that primary key, which we've already seen, and then all of our columns. So this is where it gets fun. We need to tell in this create table where our foreign keys actually are. So we have to write an extra line to say, hey, we want to set up this contract with you to pinky promises data is actually going to be there. To start this contract, we say foreign key. I'm sorry, was that a question?
Oh, I'm sorry.
Just want to make sure. Okay. So to start that contract, we use the keyword foreign key. And then we need to say, okay, inside of this table I'm about to create, where do you want to start this contract? And I say owner ID. I want my owner ID that I'm about to create to have some kind of dependency on another table. So the next question is, okay, you want to have a dependency on another table. What table are you talking about? Well, then I say, in typical English language, well, it references owner's table and its owner ID. So that's what this is saying. I want to write a contract for my owner ID in my dog table to reference my owner's table, owner ID. And then this contract is written. That's the power of this foreign key.
Can I ask a question?
Please.
So I'm curious, does it actually import that foreign key information into the boxes, or does it only reference it?
It
Like-
only references it. So it is not going to import the information. It's literally a contract. It's not going to add any more data to it.
Whatever we put in that box is going to connect it to another box on another table. But
Correct.
it doesn't import any of that information. We connected ourselves.
It is going to connect the two owner IDs to make sure they both exist in both tables. So we got to make sure a 1 and a 1 exist in the owner table if you try to add, or in the owner table if you try to add it to the dog table. And we'll see this here. I think a better way to do this would be just to show a quick example.
Okay.
So let's go ahead and create this table here. So originally we had our owner table here, or we know we're doing our dog table. So I'm going to take this create table and I'm going to edit it. So we have my dog table here. And then to edit this query, what do I need to put here to create the primary key? Obviously, with answering the name.
Primary key.
Very good. Primary key, and then what's next?
Auto increment.
Auto increment.
Auto underscore increment. Very good. There we go. And we set up everything here. So all of our columns stay the same. How do we start beginning that contract we just talked about?
Foreign key.
Foreign key.
Foreign key. And then what's next?
Column name.
Owner ID, actually. That's the one that.
Oh, yeah, and actually it would be owner ID, and I forgot something here. We're gonna be changing dog owner to owner ID here. And we're gonna say int, because that's what it's gonna be switched to. So we had to switch this column out. So this owner ID, again, will relate directly to this integer here. So owner ID, and then we say references.
Owner's
And then,
table.
I'm sorry?
Owner's table.
Owner's table.
Very good. Owner's table. I don't know why I keep it saying plural owners. It's owner table. And then owner ID. Very good. That will relate directly to the owner ID in the owner table. So this right here, again, establishes that contract. Let's go ahead and run it. Awesome. I'm going to go and refresh our tables, make sure nothing blew up. And we see my dog table here with no information in there. Now let's go ahead and quickly look at owner table just to make sure that we remember who's in there. So we see we have Kyle, Sarah, and Kyle with the IDs 1, 2, and 3. So let's go ahead and insert now a dog into our new dog table. We're gonna take, up here, we're gonna do Waggy and Odie. So I'm gonna take these two, and bring it down here. And now that we're auto incrementing, we take out that ID. Remember, if we auto increment, we don't have to include that ID in there. And now we include the values that we want to do. So we say dog name. And we do dog age. Then we're going to do the owner ID, which we'll change here in a second. There we go. And then good is good dog. Fantastic. Take those values, bring them down here. And now we're going to change Kyle to, should it be the 42-year-old one or me? Who wants to own Waggy?
You.
Me? Thank you. Thank you. A+. All right. So we're going to go ahead and insert this. And everything ran okay. We see we have our green light down there. let's go ahead and just query our dog table. There we go. Or sorry, yeah. Why is that? Oh, I changed it. My dog table and re-query that. And there we go. We have our Waggy in there. That's all good. And as you can see, no extra information was provided in here. Just because we have the link up there doesn't mean any information is being joined. It's literally just, again, a general contract that information is there. So what happens if the information is not there? What exactly happens on one of these inserts? So let's go ahead and hop over back to our query. And what if we remove Teresa? Because again, there's no Teresa here. Let's just say maybe Teresa will be owner number 4, and we'll get to it later. It'll be fine. Let's go and highlight that and run that. We immediately get an error down here. We see that cannot add or update the child row because, well, because the ID doesn't exist. The owner ID for is not there. Therefore, this contract is void. It is bad. We cannot insert this information. This again right here is a very simple thing, but also a very powerful connection we have with our other tables. So that's why we do this, to make sure that we don't make a mistake trying to insert data that doesn't relate it to something that's not there. So this is why we use foreign keys. So any questions about this or anything that you guys would want me to dive a little bit deeper into? Anything at all? How do you guys feel about foreign keys? How does everyone feel about foreign keys, primary keys? Anything you guys like? Anything you don't like?
I'm offended that Waggy is not a good boy.
I know. Oh, I was showing someone these presentations beforehand. It's like, is your dog not a good boy? It's like, it's for examples only for example purposes. Waggy is definitely a good boy.
For next class, just change them all to true, okay?
Okay. For the sake of next class, I'll write it all as true. Perfect.
Have we showed them how to do an update yet?
I had to do one early today, but you know what? Why not? Who can tell me to write an update? Alexia, talk me through updating Waggy to a good boy.
Oh, okay. I don't know how to do that.
What keyword do we start with?
Update.
Very good. Update, and then?
I guess the table name, which would be...
Which will be my dog table. Set. So we use the keyword set because we want to set something to another value. In this case, is good dog equals to true. Where, to have that conditional, dog ID is equal to Waggy's 1, right? So we'll say 1. Run that. Go back to our dog table. And thankfully now Waggy is a good boy.
Yay!
Everyone can be happy tonight now.
I have a quick. So, is there a way of updating like all the dogs to a good boy at the same time, or like accidentally like, oh, I was supposed to assign it to 1, but everybody's now a good dog?
Yeah, absolutely. You take out that conditional, and now everyone's a good boy, or a good girl, or a good dog in general. So taking out the conditional basically says rain havoc on my entire table and set everybody to true. Does that kind of help, Jeremy?
Yep, it does. Thank you.
Absolutely. Any other questions? Great questions so far. All right. So as we already saw, that foreign key and that reference there, those are the ones that provide that power to make that connection between the two tables. Once that happens, we have our ID here on dog ID, and then we have the primary key here on owner ID that is attached to owner ID. This is how we actually make that connection. And again, you're going to be seeing this as we move forward in SQL, because as we remember in Java, our objects, like our dog object or any kind of other object that we worked with, becomes a little bit more complex. Same with the data and how it relates. It's going to become a little bit more complex. So these are going to be very important concepts as we move forward. That being said, we are all done with this. These are the examples I just wanted to show you today for SQL, and really just get into those joins and get into those references and how all the data relates inside the SQL, inside of a SQL database, excuse me. So at this point, I'm going to just leave it open for questions real quick. Anybody have a question about anything we've covered, anything that anybody would want to see?
Yes.
What was that?
Kind of question. So I don't know if this is better to ask my TAs in studio or if I should ask it in class, but I was kind of confused about importing tables and how it relates to Git and CSV.
Okay.
So like the exercises told us to fork the program, then download the zip, and then use the import table wizard to get that information into our tables. But is there a better way to do that? Couldn't we use like the command line or something else to stay tied into Git? Or
so I believe Git was there too, and let me go ahead and just pull open that exercise there. You said it was the pass exercise here?
Yeah, the exercises for the SQL Sequel.
Okay, let's go ahead and open up the repo and just take a quick look at it. So we have our exercises here, and we have our CSV. So we are going to, so you're asking, is there an easier way to import the data or kind of connect it to SQL?
Is there an easier way to import it? Or, I mean, I don't know, it just seemed clunky to me.
So there's two ways that I have explored, and any of the TAs, please, anybody, especially in data, please speak up. The two ways I've seen it are just downloading gigantic CSV files. I think you can make a data connection to other servers or databases to pull it in that way, or just write a giant SQL query. So to answer your question, I have not seen a fun, pretty way to do that, because this doesn't happen too much in the real world all the time. You're not always pulling in this new data and creating databases. Usually the information is created ad hoc by your user using your data or using your app or something like that.
Okay, I didn't think about that at all.
Yeah, so it's probably clunky because this is not a typical thing we have to do, at least not on my end. But I do want to open it up to anybody in data because I'm definitely not on that side all the time. Does anyone have any say on that of like CSV files or SQLs of inserting data into databases? And if not, completely fine. If you want to share also on the general channel, if anyone finds anything, please let me know. Because I agree. I remember doing these studios and everything, and just like it's gonna take a second. So, great question. Any other questions anyone has on anything we've done today? All right. Well, I know we went a little over time last class, so this class, I'll give you guys back some time here to go work on those studios. So again, thank you very much for everybody for sticking through it with me, everybody listening, and stay healthy, have a great week, and don't forget, come back here next week, or on Thursday, because we're gonna be having class. Make sure that you're here promptly at 5:30, because we will have a special guest. So thanks everybody, have a great day. Keep going on SQL, keep at it. Graduation's right around the corner. Everyone's doing awesome.
Thank you.
Have a good one. And I'm going to go have another cup of coffee.
Thank you, Kyle.
Thanks, Kyle.
Thank you, Kyle.
Bye, everybody.
Take
Alrighty,
care.
thank you, Kyle.
Have a good evening.
Thanks, Kyle.
See you next time.
Thank you.
Bye, everybody.